this first objective. And it says, for the differential equation y prime equals x times the quantity 2 plus y, create a slope field on the given coordinate grid. B, find a particular solution to the differential equation that contains the point and solve the equation for y. Sketch the solution on the slope field. All right? So we are creating a slope field, and again, that involves plugging in points. And remember that it always is a little bit harder when it involves x and y, because there might be some patterns, but they aren't quite as obvious as if it just involves x or just involves y. Okay? Again, you can do this by making a table, but I find that very painful because it's harder to make the table than just to draw the little lines when you figure it out. Okay? I usually start at 0, 0. So if I plug 0 in there and 0 in there, what am I going to get for a slope? 0. All right? And again, there are some patterns. Wouldn't it be true that whenever x is 0, because 0 times, who cares what this is, right? 0 times whatever this is would be 0. So whenever x is 0, my slope is going to be 0. Now that's not necessarily going to be true the rest of the way, all right? Because when, for example, if I move over to 1, 0, okay, if I plug 1 in here and 0 in there, what would I get a slope of? 2. Again, I'm going to try to aim up at that point there. Okay, up 2 over 1. Okay, but when I plug in 1, 2, plug 1 in here and 2 in there, what would I get a slope of? I'm sorry, that's not 1, 2, is it? Sorry. 1, 1. When I plug 1, 1 in there, I plug 1 in here and 1 in here, what would I get a slope of? 3. Okay, and so again, I don't have much to aim at. I'm just going to make it try to look a little steeper than my other one. Okay, so these in this column are not necessarily all going to be the same. But is there any pattern for y? Anywhere that y would equal something that would make them all zeros? Decide if there's anything going on. Again, any value of y that would make all the slopes 0. So if y was what, the slope would be 0. -2. So isn't that down here, and then down here, and then down here, and then down here? Okay. So you kind of want to use those shortcuts if you can, because again, they can be painful to make if you don't think about patterns and shortcuts. All right. Go ahead and finish making that slope field. All right, so the slope field ends up kind of suggesting a parabola sort of shape, a quadratic sort of shape. But then part B says find the particular solution through the point 0, 1. So our graph's going to go through 0, 1 here. Okay. It's helpful to replace y prime by the more formal notation for that, which would be dy over dx. So go ahead and do that with me. And we can't solve this differential equation until we separate the x's and the y's. The dx always has to come off the bottom. And then what on this side wouldn't belong? The y. And if the y goes, because 2 is added to it, 2's got to go also. All right? So you're going to divide both sides by 2 plus y. It's kind of a ugly step. So right now I've got dy over 2 plus y equals x dx. And I do want to integrate both sides. Talk about with the people around you how that thing might integrate. So this side, again, if we were to rewrite this, that would be 2 plus y to the negative first. What does that negative 1 power tell us this is going to integrate as? A natural log. So a natural log of the absolute value of 2 plus y. Do we have to worry about the derivative of 2 plus y? Do we have to worry about the derivative of 2 plus y? No, because it's just 1, right? All right. And on this side, what about x? How does that integrate? Half x squared plus c. We want our plus c somewhere, all right? It can go on the other side, but if we're going to solve this for y, which it asks us to do, it's just easier to put it over there, okay? Now at this point, we have a decision to make. We need to decide if we want to plug our point in now or after we solve it for y, okay? And when you have a calculator, it doesn't make that big of a difference, but I'm trying to think ahead to the AP exam. And if I was to plug this point in here now, I really can't tell you what the natural log of 3 is. All right, I don't know that. So I'm going to solve it for y and then plug the point in. Okay, so do that with me, please. E to the, guys, quit playing with that. This power equals this. So e to the 1/2 x squared plus c equals 2 plus y. The absolute values can be removed from the 2 plus y now because when you raise e to a power, it can't be negative. All right. This is where that kind of magic happens, where we split this into 2 powers of e. So those would be e to the 1/2 x squared times e to the c. Again, when you have 2 powers with the same base, you add the exponents, and that equals 2 plus y. But again, for ease in calculation, if e to the c is a constant, why not just call it a constant rather than e to the c? That's going to make it difficult for us. So we're going to change e to the c to big C, and e to the 1/2 x squared would stay that. Connor, are you here? And then you would subtract 2 from both sides, and then you would get just y. Now I think it's going to be easier to plug in 0, 1. Okay? We don't know c, but we know that x is 0, and we know that y is 1. Okay. So c times e to the 1/2 times 0 squared minus 2 equals 1. Well, 0 squared is 0. 1/2 times 0 is 0. E to the 0 is 1. So we get c minus 2 equals 1. Or we add 2 to both sides, and c equals 3. Okay. And then I plug that in here. And my final answer, my particular solution, is y equals 3e to the 1/2 x squared minus 2. And again, according to what my slope field looks like, if I graph the point 0, 1, which is right here, it looks like I should have this kind of thing going on. But what I would do for sure before I left this problem, because I'm not going to take your calculator away from you, is to make sure that that's the kind of graph I get. Okay? So do that a minute. Make sure that that graph fits nicely on that slope field. Now, a good thing to make sure you're doing if you're going to check a graph against a calculator is use this window. So if you guys did Zoom standard, I mean, it's probably enough to figure it out. But I just typed in -2 to 2 for my window, okay, to make sure it looks like that. So I think we're good. All right. Moving on to objective 2, or number 2, I'm sorry. You don't have to solve this differential equation. You just have to graph the slope field, okay? And it is one where it just has an x. So think about with the people around you, try to remind the people around you, when the slope field involves just x's, are the ones in vertical bands the same or horizontal bands the same? Decide with each other. Which way do we have slopes that are all the same, vertically or horizontally? Vertically, yes, okay. And if I start at 0, 0, I get a slope of undefined, okay? Now, most of the times people leave that blank. Some people will put a little vertical line here, okay? Because, you know, a vertical line has an undefined slope, but most people just leave those blank, okay? So then we move over to 1, and when I plug 1 in there, 1 divided by 1 is 1. So I'm going to, again, I'm trying to aim up 1 over 1, okay? These are all going to be 1. When you plug in 2, remember that it's 1 over 2. So 1 over 2 would be a half. So I want to make it not as steep as my slope of 1. Right. Figure out what's happening on that other side. All right, and that should kind of make sense. Again, even though you don't have to solve this, if we did, we move the dx over, it would integrate as a natural log of the